submission for Master's Project RentARoom by Joshua McCann, student number 400599274. The main code repository for RentARoom can be found at the following URL in GitHub. It can be cloned to your local machine using standard GitHub processes. Opening the RentARoom solution in the Visual Studio IDE shows that the solution consists of 6 projects. Opening the RentARoom web app shows us the root files, JavaScript and CSS, areas for different role types which contain the controller and views, the hub classes for signal R requirements, the shared layout view, the app settings, and the program file. I would suggest instead of using the app settings to use user secrets instead. The Data Access project provides application DB context and migrations for accessing the database. The repositories, including Unit of Work, provide data access layer for the models. The Models project holds the code used to generate the database entities, with some additional data transfer objects and view models for more complex, bespoke requirements around the application. The services layer manages the majority of business logic through the RentARoom application, through the concrete implementations and their interfaces. The Test project contains the integration tests, test files, and unit tests for RentARoom. The Utility project provides global level helpers and variables for RentARoom. RentARoom is continuously deployed to Azure through GitHub Actions, which uses a .yml workflow file that builds the solution, runs unit tests, runs integration tests, and then deploys to Azure through the URL endpoint shown here. That's defined in the Azure portal under the domain. And also in Azure portal we can see the app service and app plan which run the web project. We can see the SQL Server and DBs which operate the database. And we see the Key Vault which contains sensitive configuration variables for the Azure environment. To help developers run RentARoom locally, either for testing or future development, the README documentation provides background and link to helpful setup instructions which can be clicked through, or you can click through to the file. The setup instructions then bring up the documentation that shows the software required, the steps to run and clone the repo, setting up the database, using user secrets, and also the key dependencies that are required to run RentARoom. For user acceptance, use case 1, test 1, we see the database for the Azure environment via SSMS. We see the 6 properties in the property table, and we navigate to the URL for RentARoom, and we can see that all 6 properties are available to the user. For user acceptance, use case 2, test 1, when on the landing page of RentARoom, of the 6 properties, only one is a bedroom type with postcode BT9. If a non-logged in user enters the search of BT9 for room only, they will be returned to 12 Hillside Drive. For user acceptance use case 2, test 2, if they enter an empty string for search, it returns all properties. For user acceptance use case 2, test 3, if they enter unmatched criteria, it will return a placeholder for the user. For user acceptance use case 3, test 1, the user clicks on the details button, which brings the property information to the user. For user acceptance use case 4, test 1, the property details view will show the user the email and phone of the respective agent. We can check this in the database for 24 Kings Row, which shows this application user ID matches the agent@gmail.com. For user acceptance use case 5, test 1, the user navigates to the map page. They expand the map controls, interact with the map, zoom out to see a clustering of icons, click to see a point of interest, and can remove the layers. They also click on the property icon and they can click through to view the details of the property. For user acceptance use case 6, test 1, the user is logged in and clicks on the map where they want to add in a point of interest. They proceed to add in the details to the modal to save for the point of interest. Once saved, the user can click on the icon to view details. If the user logs out and logs back in, they will see the point of interest on the map and data table as it has been saved to the database. For user acceptance use case 6, test 2, if the user is logged out and tries to add a location, a modal prompt to register or sign in appears. For user acceptance use case 7, test 1, the user is logged in and has a custom location saved. If they navigate to the property icon to get the view details for that property, they can select Get Travel Time with the profile selected. This will return the distance and time it takes to get to their custom locations. For user acceptance use case 7, test 2, if the user is logged out and tries to get the travel time, a prompt will show them to register or log in. For user acceptance use case 8, test 1, the agent logs in and clicks Create New Property. The agent has input the data and hits the Create button. This then adds that property to their data table, also adds it to the landing page so users can see it. For user acceptance use case 8, test 2, if the agent inputs incorrect data and hits submit, validation messages will show in the UI to help them. For user acceptance use case 9, test 1, the agent is logged in and clicks on the edit button for the property they wish to add an image for. They choose file, they select the image they want to add, then they click update. This then saves for that property and shows to the user, both in the details and in the landing page. For user acceptance use case 10, test 1, the agent is logged in and clicks to edit the property they wish to update. They can choose to remove images, and they can also choose to update different fields, such as the address, the postcode, and rent. If we update this, we'll see it updated for the property in the data table, but also in their details pages. The agent can also choose to delete the property, which will remove it from the data table, but also from the landing page for users to be able to view. For user acceptance use case 11 test 1, a user John is logged in on the left hand side. They scroll to the property they're interested in and hit the message the agent button. Click and start chat, then it opens up the chat window where they can enter their message and click send. This appears as a notification icon for the right hand side logged in agent. They click this icon, brings them to the conversation windows, which they click to open the chat window. Here they input their message for a response, which then fulfills user acceptance use case 12 test 1, as we see it appear for the user. For user acceptance use case 13 test 1, an agent is logged in and is at the property's data table. The data table shows the number of days the property has been posted and its total views. Clicking into the property details view will show a chart.js graph of the views per date, also the total view count, which can be updated on page reloads. For user acceptance use case 14 test 1, a user is logged in. They create a custom location, which we see populates the map and the data table. Next, we check the database to make sure the location has been added and that the matching user ID matches the user that created the location. We log out as the user and we log back in so we can see the location persists on the map and the data table. We see this is the case for Falls Park, which we just added. When the user is on the map page, we can see in the URL that it's the user area, the map controller, and the map search view. Navigating to the code, we can go open up the web project for RentARoom, expand the area section, find the user, and we can see the related controllers and views. In the map search view, we see relevant dependencies for leaflet map, CS, and JS loaded in first. Then we see the structure provided for the datatables.net API locations table or points of interest table. We see the modal for editing or adding a location or point of interest. Then we see an authorization modal for the user if they're not logged in. And finally, we see the relevant JavaScript for RentARoom in the scripts section. We can navigate to this JavaScript file by going to the root folder, JavaScript folder, and then look for mapsearch.js. In mapsearch.js, we see the map defines OpenStreetMap as the tile layer, cluster groups for properties and locations, and bespoke property icons. Then it fetches data through API calls to our map controller to populate the map. Then additional code to handle the response, but I want to focus on a particular area for data tables. Here we see that the data tables API function call for data table then uses an internal API call to get data to populate the structure defined within our view. If the user is on the property details page and selects get travel time, it will call an API to return the distance and the time it takes from this property to their points of interest. In our travel time JS, which is loaded in via the details view, we see there's an event listener for page load and for calculate travel time button click. This eventually calls an API method get travel time within our home controller. Whenever we go to this get travel time method, we see it uses our travel time service to get travel times async, which returns results back through JSON to our travel time JS to present to the user in the UI. Within travel time service, the API key for OpenRoot service is retrieved either from app settings or user secrets for locally running instances, or Azure Key Vault for the live instance. Get travel time async gets user locations and property data and calls get travel times and distances async. This is where the request body is prepared and the request is triggered for the external API call to OpenRoot service matrix API. There's a handle API response which returns it in the correct JSON format expected of our original JavaScript file. The images used across the RentARoom app are managed by agents when they create or edit properties. In the database for 17 Gorfin Street property ID 2, we can see there are many image URLs associated to one property and many to one relationship. The property controller handles the creating or editing of properties via push request on the upsert view. We see it uses the property service save property async method. Checking this method, we see it uses the property ID to determine if it's a create or edit. If it's a create, it maps the DTO to a new property, then uses Azure Blob service upload file async to manage the images. Else, it's an update where it maps new changes to fields to an existing property, but also uses Azure Blob service upload file async to manage images. Then unit of work is used to save the image changes and then overall save the property changes. The Azure Blob service is where the configuration for your Azure Blob storage connection string and container name are retrieved and assigned. The service also uses the image-sharp image object in upload file async to reformat it and set it as WebP, and we see that in the WebP encoder here, to reduce storage size. On the Azure portal, I use a blob storage account RentARoom image. The container has all the WebP formatted image, each of which has a URL saved to the database that points to that image. For reference, the user acceptance tests, part 1, part 2, the use case diagram,